We look at the derivative today, huh? So let's talk about derivatives. The derivative of a function will give you the formula for the slope of the tangent line. That's something that you need to have in your brain, stuck, always, always, always. So here, the derivative of a function gives you the formula for the slope of the tangent line for a given x value. I don't know if I said the formula for the slope. I think I did. But that's one way to think about it, if you were thinking about maybe the graph. Or if you're thinking about some contextual problem, it would be the instantaneous rate of change. Or you could say, or the instantaneous rate, formula for the instantaneous rate of change. Instead of slope of the tangent line, you could say formula for the instantaneous rate of change of that function. So there you go. That line can be replaced. Some notation, if we want to say the derivative of f of x, so like say we have f of x here, the derivative could be written, so this is just the function, and then the derivative. I feel like the most common way, if it's written like f of x, you could say f prime of x, that's the derivative, or you can say df dx, that's the derivative with respect to x. This is known, I'll do it in a different color. That's a horse of a different color. What? The dx, that's the derivative operator. And you can say, so if you say ddx, like this, you would say the derivative of, and then whatever is here, so f, with respect to x, that's this part, that's the dx part, sorry, there you go. So that's some notation. We have the limit definition of the derivative, which we looked at last time. There's two, but I'm only going to make you use one because it's the easiest in my brain, for me. I don't know. So that is the limit definition of the derivative. Maybe I'll put a box around it because it's important. And there we go. So those are these quick notes, some notation. And then so the prime notation. We could also have, like, if we had something like I'll do it in red and stop it right there. So if we had y, we could say y prime or dy dx. Actually, that makes better sense. So if you had a function y, you could say y prime or dy dx. For a second derivative, which we won't get to yet, but you could say d squared f over dx squared, or f double prime, same. Or you could say, like for the other ones, y double prime or d squared y over dx squared. The dx is called a differential. It's like tiny, tiny, tiny changes in x. It's kind of related to like change in f over change in x, delta d. What? Delta f and delta x. It's related to that. That's where the notation comes from. And then the prime notation is just a lot quicker to write. But this is more explicit. So it's telling you with what variable you're taking the derivative with respect to. I think that's all I'm going to write in this video. Just some notation. Remind you of the limit definition of the derivative. It gives you the slope of a curve at a single point, or the slope of the tangent line of a curve at that point, whatever x value. Or it's the instantaneous rate of change if you're thinking about it in some kind of other context. Okay, goodbye.